Hello again, Twisted Weather Freaks, and welcome to the long version of the Weather Risk Winter 2018-19 preview. This one will probably run about a half hour. It's got a lot of meteorology in it, so let's get right to it. All right, first I want to go over my key assumptions here about this winter. Again, if you have seen the short version, this part is the same, but later in a couple of slides you'll see vastly different information, so just hang with me. Again, weak to moderate El Nino, that's a certainty. Mordecai El Nino, I believe that's strongly going to happen, and it's very different. We'll see how it's different in just a minute. There's also a large pool of warm sea surface temperatures which have developed just off of in the Gulf of Alaska, off the Northeast Pacific. And again, it's very similar to what we saw in 2012-13, but especially 13-14, where that cold water, that warm water there locked the pattern in place, and we had several severe Arctic outbreaks. The Arctic Oscillation consistently came south, came negative. And what it did was it developed a strong ridge from Western Canada moving up into the Gulf of Alaska. When the ridge does that, that's known as the positive PNA, and when it expands into Alaska, it's called the negative EPO. So what that does is that establishes a cross-polar flow. So the Arctic air from the poles and from Siberia can be brought straight over into Canada. That's why that warm water in the Gulf of Alaska is important. We also have a weak sun. The sun's very weak right now. The weakest, it's in a very weak cycle to begin with, but more importantly, it's going to the bottom of that cycle, which is what we saw in 1995, 1996, and 2009, 2010, which were both pretty big winters. Also, we see the QBO is changing rapidly. The values in July was minus 32. Now it's around minus 9.5 as of October 1st. And the data and the research shows that when the QBO is close to negative, minus 10 to minus plus 10, minus 8 to plus 8, something like that, it allows for more blocking patterns in the jet stream. Soil moisture, again, widespread excessive saturated conditions over the Midwest, the Mid-Atlantic, the Deep South, favors keeping the mean trough over the Mississippi Valley, and that in turn increases the chances of seeing more low pressure areas developing in the Gulf Coast and coming up the East Coast. The European climate model, last 4 runs, has been very aggressive, very impressive. July, August, September, October, showing a pretty active and stormy winter for the eastern half of the country for this upcoming year, winter. Some areas are below normal. A lot of areas are close to normal temperatures, but the precipitation looks pretty impressive. And the other thing is, all the other climate models in October, the Japanese, the Canadian, the British models, have all turned in the last couple of weeks dramatically towards the European climate model. So in our technical discussion, like I said, we're going to go into the whys, wherefores, and the meteorology here. So let's start up and taking a look at the El Nino area. Now this is the El Nino zone. Some of you may know of this, some of you may not. There are 5 different areas of it, you can see. Zone 1, Zone 2, which is off of Peru. Right here, it's often referred to as Zone 1 and 2. It's actually 1, Zone 2, and then Zone 1 and 2, and then Zone 3, Zone 3 and 4, and then so on and so forth. So I guess technically you could say there's almost 6 zones. Anyway, the key section that gets the big focus is here, this one, the central area. So when the ENSO 3.4 is warmed, normal sea surface temperatures of at least plus 5 degrees centigrade for several weeks, the El Nino is declared, and when the ENSO zone 3.4 has colder than normal sea surface temperatures of minus 0.5 degrees centigrade or colder for a few weeks, La Nina is declared. So this just gives you an idea of what actually the area is. This is a nice graph. It shows all the La Ninas and El Ninos, weak, moderate, strong, since 1950. So this line here is the strong line right here, 2.0. This is moderate, and this is weak right in that area. So there you go. And same thing down here. This is the strong La Nina, and you can see the strong one here back in 73, 74. And 88, 89, you can see those strong ones, 2010, 2011, so on and so forth. 11, 12, which was a snowless winter. And then the same thing with the super strong El Ninos. You can see them up in here as well, 2015, 97, 98, 82, 83, 72, 73, and so on and so forth. So another way of looking at that data is looking here. Now this is a graph. It's broken down into weak, moderate, and strong, very strong El Ninos, La Ninas. This is just by category. This you can actually see the intensity and the peaks and so on and so forth. So either way, it's the same data. I just want to show you different ways of presenting the data. This is the current, as of October 20th, the sea surface temperatures. So right here, okay, this is the equator right here. All right, so over here is Indonesia, and over here is Peru. You can see this warm bubbles of really warm ocean water temperatures coming up rapidly now to the surface. And you can see that it has taken off. In fact, the new one as of November 2nd is now +1, if you can believe in that. Centigrade above normal as of November 2nd. So there you go, it continues to warm. Most of the El Nino models here, we have 26 different climate models. The next 10 months, the green line, that's the mean, the average. And as you can see, just about reaches 1 degree centigrade right here, a little below it in the middle of the winter, and then it begins to drop off a little bit. So we're not seeing anything strong here at all, nothing strong, and only a few get to moderate. So it's probably going to be weak El Nino, but it could be moderate. This here is the European model, and the upper left is September, the bottom right, this is the October run. The new November one will be out around November 5th, November 6th, and you can see there are a few diagrams, spaghettis here, which get it to strong, but most of them are in the moderate to weak category here. So we believe that's going to happen. I believe so. We're going to operate on that assumption that's a moderate El Nino or a weak one. This is the Australians, and the data has not really changed for Australians. They keep it moderate right through 1.2, 1.4, right through the heart of the winter. Now, why is this important? Well, this is why. Okay. This diagram here shows all El Ninos and the temperatures for the winter. And you can see generally it's cooler than normal because of cloud cover precipitation here and warmer than normal here. Okay. Now this one on the upper right shows temperature anomalies when you have a weak El Nino. And you can see the Northeast, the Mid-Atlantic, Ohio Valley, Great Lakes, colder than normal. Now the one on the bottom left, this is moderate. And you can see it's very relative to normal, pretty cold to the south, all the way into Pennsylvania, but really warm to the north. And then finally over here, this is strong El Ninos. Everybody blow torches in a strong El Nino, generally speaking. There you go. And if we break it down this way, December, January, February, what we're looking at here is a weak, let me call my marker, a weak El Nino. And as you can see, the eastern half of the country is cold all the way through. Even if it's moderate, January is still normal, which is a cold month in the Midwest and the Northeast, still pretty close to normal, and then February and March turn out to be gangbusters. So the one thing we don't have to worry about based upon all the data, and again we're assuming this, is not a strong El Nino. Okay. Another way of doing this is nice information from the Climate Prediction Center. They've taken every single El Nino since 1950. They've broken it down by strong, this group right here, moderate, and then weak over here. And this is just precipitation. Now the thing is, if you notice this, okay, when you get to moderate and weak, some areas are quite wet and some areas are not. So there you go. It's especially when you have weak El Ninos. For example, the 79-80 El Nino is pretty dry down here, but the 51-52 is pretty wet. So you have a lot more mixture here in the weak El Ninos. And these are temperatures, the same sort of thing. Again, look at the temperatures. All the strong El Ninos, really quite warm. You can see that. Okay? The only one difference, 57-58, and that was borderline strong. Moderate here, you can see that some of the 91-92 was quite warm in the plains of the Midwest. But other one, 94-95, was close to normal temperatures in the eastern United States. And some of them were cold. Here and here, 63-64, so on and so forth. 65-66. And then you have the ones and the weak ones. And again, the weak ones very different. Again, some of them warm, and then some of them 70 look really cold. 58-59, 76-77, 69-70. So very hit and miss. Okay, so we're going to assume or entering a weak or moderate El Nino. That's our key assumption here. Okay, good. Now, not all El Nino events are the same. That's why you have that disparity. There are two different types of El Nino events. The classic El Nino event is this one. Develops off of South America and goes out to the Central Pacific. This is the Central Pacific, also known as a Molokai El Nino, also, or CP, centrally based. And it is, as you can see, in the middle here. And it's actually not that warm off the coast of Peru. Now this shows an example of two powerful El Nino events, the 82-83 came off of South America, and this one 1997, 1998. And again, if we go back up here, we can see that both of those, here's the 97, 98, that was super strong, and then 82, 83. So I just want to point that out to you. Okay. Now this is 2015-16. Remember that El Nino we had a couple years ago? That sponsored the big blizzard, helped produce the big blizzard in January of 2016. And we can see, or was it 2015? I forget which. Anyway, so you can see the El Nino developed very strongly here, and then it pushed out this direction. Now this is a Mordecai El Nino, which happened in the winter of 2009, 2010. And you can see the warmer water temperatures are here, and it's actually a little below normal off the coast of South America. So the issue is what's going to happen this winter. This is the October 1st run of the European climate model. And as you can clearly see, it shows a Mordecai here in the Central Pacific Ocean. Clearly does that. The Japanese model also shows that as well. So again, we're going to operate under the Mordecai assumption. Now, if we take a look at it, of all the El Nino events in the Pacific since 1950, there are 21 of them. That does not include 2015-16. So again, 15 and 16 would be down in here, 15, 16. Okay. So if you look at the ones with the stars, the red stars, these winters were colder than normal over the eastern U.S. 11 of them, I believe. So and then these winters, Mordecai here, were warmer than normal. And that's probably for the other reasons not related to the Mordecai. So as you can see, there is a tendency, but it's not certainty, of these 21, 13 of the 21, which were centrally based Mordecai El Ninos, were pretty significant winters. So there you go. So 13 of the 21 of the total were Mordecai, or centrally based Pacific El Ninos, and most of them were colder than normal, but not overwhelming and not certainty. This shows you what happens when you have the jet stream pattern here. So briefly, what happens is, let me change the marker so you can see this a little better. When you have a typical El Nino, the trough is on the west coast and the ridge is here. So all the low pressure area goes this way. The temperatures are above normal. Because the low pressures are tracking here, it pulls up the warm air. Okay, great. Now, when you have a Mordecai El Nino, different pattern completely. Here you can see that it's going in this direction, and your trough is like that, and you get more storms over the Mid-Atlantic, the Midwest, and New England. And if we can do a comparison, we get this. So this is the typical El Nino pattern. California gets hit a lot. See this? Boom. That's why California gets hit, and it's warm here. Here, California gets hit, Southern California, but so does everybody else. So it's a different setup completely. And the ridge is over the west coast of Canada, and you're getting colder southward, and that's why you get snowier and colder weather patterns. So the key assumption, okay, so we did the El Nino. Now let's talk about the warm water here on the Gulf of Alaska. Besides El Nino or La Nina, large persistent pools of warm cold water, sea surface temperatures, can and do impact weather patterns around the world. In North America, most weather systems go west to east. So the northern Pacific Ocean can have a major impact on weather patterns, especially when there's a big pool of warm water, cold water there. When the warm water is very strong off the coast of North America, it's called the positive PDO, Pacific Deckhead Oscillation. Positive PDOs that are strong have a big impact on weather patterns. And you can have a negative PDO when you have cold water there as well. So it's not all just one thing. This is what happens. Let me show you. When you have a negative PDO, see the cold water here? It produces a trough on the west coast. See that? So the negative PDO connects to the negative PNA. When you have a positive PDO, the warm water here, you get a ridge on the west coast. See how that works? You get a positive PNA. There you go. So that's pretty darn nifty, and it works a lot of the time. Let me show you an example of what I'm talking about. This is from the winter of 2013-14, which was a horrific winter. If you remember that, a lot of cold, a lot of snow. Many companies ran out of salt, snow removal. They simply fell apart. They didn't have it. Constant barrage of storms and snow and cold. Not monster storms, just 3 inches, 6 inches, 8 inches, what have you. Look at the warm water there in the Gulf of Alaska. You can see what it did. It forced the jet stream to come out in this direction here and brought the cold air in. And you can see, look at the temperature anomalies for the entire winter. Good googly moogly. That was a cold winter. And the thing is, and here's the thing, it continued the next winter. Here it is, 13-14 winter. Look at that. That was some of the warmest water we ever saw in the northern Pacific. Okay, and look what the winters were like. January and February, boom, east of the Mississippi River, cold and snowy. So there you go. Now what's going on right now? Mid and late October, here's the sea surface temperatures. We have a huge explosion of warm water in the Gulf of Alaska and the Bering Sea. That looks like a repeat to me, folks. So I think this is significant. I think this means we have a positive PDO coming. So this is the PDO data table. I just want to show you what this looks like so you can see it's pretty impressive. So what we want to do here is we want to look at all the PDOs that were positive all winter long. Okay? And El Ninos, which were weak or moderate. Let's look at those combinations and see what we get. Okay? What we get is this. We get the winter of 58-59, 69-70, 76-77, 77-78, 2004-2005, 2006-2007, the winter of 86-87, 87-88, 91-92, 2002-2003, and 2009-2010. Whew. But the upper air pattern, you can see what it looks like. It's just awesome. This is for the whole winter, as you can see right here. And we have a persistent PNA, negative EPO, strong ridge here in Alaska, strong blocking over Canada, negative NAO, negative Arctic oscillation. And look at this negative trough over the east coast of the United States. Good googly moogly. That's a storm signal. And you can see the temperatures are really quite cold. Now if we break this down month by month, okay, this is December. Now notice the negative anomaly is more over New England here, I think. It's still fairly cold, but more over New England. And getting a strong Arctic oscillation. The NAO, not that strong, not really negative, more like neutral here, I think. But it's a pretty cold pattern here in the eastern United States. The EPO is neutral. We're not getting ridge in Alaska. It's only on the west coast of Canada, so it's an ordinary flow of cold air. All right, this year is, this is January. I missed a slide. That was December. There's, wait a second. Oh, I thought I had it here. December. There's February. Don't tell me I missed January. I did. How about that? Anyway. All right, I found my January slides. I just inserted them into the video here so you can see them. Now this is January, and you can see January, a pretty strong negative Arctic oscillation and very strong negative NAO. And then in Western Canada, we can see we have a strong ridge and a negative EPO. And then we have a strong negative anomaly over the east coast into the Tennessee Valley. And look how cold all of January is on these anomalies. That's pretty darn impressive. Excuse me. And then February, this here is also a really impressive looking signature. I mean, wow. The only thing you're missing here is a big negative EPO. You have a little bit of one, but not much. Again, very strong blocking, Arctic oscillation and NAO, and really strong signal for the East Coast, Eastern U.S. for big winter storms. And then slide 31, this is a March. Pattern begins to break down a little bit in March, but notice it's more of a suppressed pattern here. A big negative anomaly over southeastern Canada, right here, and then one over here. So that might force the storms to stay to the south. So this could be more of a suppressed pattern here with additional winter weather. And that's been a common thread through all of March. If you look at the Marches for the last decade, 7 of them have featured above normal snowfall in the Ohio Valley, the Great Lakes, the Mid-Atlantic, and New England regions. All right, so we got through March now. Let's talk about the QBO. A negative QBO is rising to neutral levels this winter. Now, the quasi-biennial oscillation in QBO is high-level wind at the top of the atmosphere, 30 millibars, almost on the edge of outer space. It's over the equator mostly, and it goes from east to west, which is the negative phase, then it goes neutral, then it goes west to east, which is the positive phase. Now, the cycle can take anywhere from 18 to 30 months, but what happens is that when it's in very particular phases, strongly negative, moderately negative, strongly positive, neutral, it can and will have a direct impact on the weather patterns over in the jet stream. So let's look at that and we'll see how it works. This is the QBO data going back to 1948, and again, just want to show what the data looks like, what we have to go through. So what? Why is this QBO thing important? Well, like I said, strongly positive QBO values relate to non-blocking weather patterns, which means you don't get a lot of cold air outbreaks, which means you don't get a lot of storms. Strongly negative QBO values, minus 20, minus 25, does the same sort of thing. And then QBO values, which are near normal, seem to favor blocking patterns in the northern hemisphere in the cold months. November, December, January, February, March. So this year is the latest data here. This takes us to October. And we can see what's happening here. The values here for June, July, and then how they dramatically have shifted here. Look at the rapid rise here taking place. So this is minus 32 at one point, minus 25 in August, and you can see where it is now. It's rapidly minus 8, minus 9. So it's reasonable to expect the QBO to be somewhere around minus 5 to plus 5 this winter, minus 8 to plus 8, something like that. So we're going to operate under that assumption. And when you do that, you get these analogs along with a moderate El Nino. These are all had near neutral QBOs, near neutral QBOs here, and moderate El Ninos. So we're going to operate under that assumption. And when you do that, when you cross them, this is what you get. Again, now the difference here is that we do not get a big ridge on the west coast. We get much more influence of the Pacific energy, but for a huge block over Greenland and Canada, and a strong negative anomaly over the entire eastern third of the country. So this would be a very impressive looking pattern for the whole winter as a whole. Let's take a look at the sun cycle. I talked about how we believe the sun cycle is weak. Now this is a chart going back to the 1960s, and notice that in every one of these examples, let me move this up so you can see it a little bit. Every one of these examples, you can see we had, this was the winter of 2009, 2010, and 10, 11. And then E was the big winters back in the mid-1960s that were pretty bad. D, the 1970 winters that were pretty severe. C was not very significant, but we had a lot of major El Nino and La Nina activity at the time, which overwhelms the sun cycle. It's much more important than that. This year we don't, we have a weak sun and not as particularly strong El Nino. So the argument goes it's going to be give it increased chances of seeing a pretty significant winter over the eastern United States. So this is an example. You can see this in more detail. This was the big winter of 2009, 10, and 10, 11 down in here. And this was 95, 96. Okay? So this is where we are right now. You can see we're right here. So now, whether or not, it gets that an impact on the winter, we don't know, but I think it is. You can see this was the peak, and notice the peak is really, really weak compared to the peak here. So there's definitely a very weak sun here, no doubt about that. All right, and the reason why that works is this. This image shows the upper air jet stream patterns, 500 millibars, 300 millibars. And when the sun is really weak, you see these green and orange areas, the yellow areas? These are all represent blocking patterns, strong positive anomalies over Greenland, the Arctic region. And they force the pattern to turn quite cold and stormy in February and throughout the whole winter, and March for that matter. Not so much December, but definitely the second half of the winter. When you have high sun activity, you don't get very little of this activity here. You don't get much at all, and it's a very normal winter. So that's the argument behind it. Let's take a look at the Siberian snow cover. And you can see there's a map of Siberia and what it means. Now, the argument behind Siberian snow cover is that it helps drive the Arctic oscillation into the negative phase. And it also supplies the supply of cold air. Okay, the supply of cold air. So that's why it's important. It does two different things. Now, the Siberian connection is not more important than a strong El Nino. It's a factor, but if you don't have a strong El Nino or La Nina, then it's a factor to take in play. When you do have them, it's not really that big of a deal. Now, as of October 15th, we got off to a really shitty start with the snow cover. And you can see it. These are the graph here of recent snow covers. And you can see the black line here. This is the recent one. You can see it was only 1 year was, and the last 10 was weaker. And that was the winter of 2010, 11 and 12, which was the snowless winter. So this was off to a bad start. But if you follow the model and you follow the pattern, which I do in Russia because I have to for my commodities forecasting, you know that that was not going to last. And I posted many times on my Twitter account that the pattern was going to change. Now this was October 25th, and suddenly we can see the black line exploded northward in terms of snow cover. Look at the explosion here. Gone from this to this. That was a big increase. And then finally, again, I posted this on the Twitter page. You can see there was going to be a big increase. And if we look at the actual final data, boom. Okay, so we can see, take a look at where it is. The black line is here. The red line is 1718. And the this line here, the purple line is 2009, 2010. So yeah, it's pretty close. It's pretty darn impressive. Let's take a look at the soil moisture. Again, a lot of forecasters don't do this. I do. When you have large pools, we know this in the Atlantic Ocean, of cold water, warm water, like El Nino or La Nina or PDOs or what have you, a warm Atlantic Ocean, it can and it does affect the climate patterns long term for the season. Similarly, large areas of saturated ground and drought can and do affect weather patterns. Large, sustained areas. Okay? Key term there. Let's take a look. This was the climate map here for soil moisture map for November 2009. You can see it right in here, November 2009. See how wet it was in this area. What this did was this kept the mean trough like this, which is why you had so many winter storms and why it was fairly cold. That's what that did. A lot of people don't recognize that. They don't give it any credence. That's fine. This is what I'm doing. Okay, now this is October 2018. Let's compare. 2009, 2018, 2009, 2018. If anything, it's actually wetter in the mid-Atlantic states here. This would argue for even a broader trough. So there you go. Something to keep in mind. Another piece of the puzzle. And finally, take a look at the blocking patterns here. Besides that, there's also the sea surface temperatures in the Atlantic Ocean. So let's take a look-see here. Now, this is a schematic of what the sea surface temperatures look like in the month of May, which correlate to a negative NAO in the winter months. So what we're looking at is a big pool of warm water off the East Coast and here, Western Europe, and then cold water here. This is in May. And for some reason, there's a correlation to what it does during the winter. Not exactly sure why. So we take a look at that. We can see this was in May. What do we see? Pretty darn close to that. Look at all the cold water there and the warm water off the East Coast. There you go. So, and you can see some warm water off of Western Europe here and in here. So that's a pretty close indication that we might have an NAO this winter, at least at times. Let's take a look at climate models. All right. This was the September climate model from the European model for December and for January. And what this is showing, as you can see, a bit of a trough here, something like that. And this is January. Monster blocking here and persistent troughiness like this for January, as you can see. And then if we go October 1st, look at that. More of the same. The trough, the negative anomaly over the eastern United States gets stronger. You can see very strong here and here. So this is a big ridge and pulling on the cold air for December. That's a pretty impressive looking map. And then for January, same sort of thing. A big block here over Canada. So it's like this. This would mean Canada and Central Plains might be pretty mild. But this would be a good storm track for the south. And then this is February, September, and March. And then this is the update. More of the same, February. See the negative anomaly over the eastern United States right here? See this? And then look at it in March. Okay? That was September. Now this is October. Boom! Wow. You don't see that every day from a climate model. Now this is the Japanese climate model. A big change from September. It's turned significantly colder over much of the country and fairly wet over the southeastern states. This was the British model. Came out October 1st. You can see the 850 anomalies are well below normal for the most of the winter over the Midwest and the eastern United States and the deep south. And if we look at the actual model, this here is the British model from October 1st. Again, this is October 1. And you can see it's got a nice ridge. This is December and this is January. So again, this is a decent supply of cold air. There's not None of these patterns look particularly warm. So that's kind of interesting. And then this here is February and March. And here we actually have it. If you look at the blue, you can actually see it. See this little blue area in here? That's a negative anomaly right in here and here. So that's where storms are likely to form and track up in this direction, which is good for East Coast winter weather if you like that sort of stuff, and who doesn't? So there you go. That's the British model. So that's turned. So there you go. And finally, now again, I'll go over the precipitation. As you can see, this is for the weather maps in general, December, January, February, March. You can see I definitely favor the precip right through this whole area, and the temperatures generally pretty cold, as you can see, all of here. So there is that. And then again, as I showed you in the short slide, this is the snowfall map. You can take a look at that, and you can see I am pretty bullish with the snow over the Mid-Atlantic, New England, into the Tennessee Valley, the Upper South. I really am. So if we break it down month by month, here we go with the precipitation and the temperatures. Yes, I have changed and corrected the dates. I know on the original version of this, I did 2017, 18. I have no idea why. Fridays are very long days for me. I do whole bunch of commodity reports early in the morning for a bunch of firms. And then usually I'm up at 6 a.m. and I'm functioning on 4 hours of sleep with an afternoon nap if I'm lucky. So I guess that's what I made the mistake. Anyway, let's get back to this. I've got these updated maps and temperatures. But again, so let me go over this briefly. For December 2018, the precipitation map here, we have it below normal in the Pacific Northwest and over the Rockies, and that's not really a surprise given the strength of the ridge that's gonna be there. So I'm pretty confident about that. If there is an area in December that I'm uncertain about, it's probably the near normal for precipitation. The data continues to show pretty strong southern jet stream here and a lot of moisture along this area, so I'm going to stick with that. For temperatures, the mean trough is kind of in the Midwest and over the Delta and a little bit into the eastern U.S. So for the time being, I'm going to have this large area of below normal temperatures in here, but this could be a little further east, and then near normal on the East Coast, the northern Rockies, and above normal here. So I'm pretty confident about that for December. And then we'll take a look at January. This here is precipitation or temperatures. Precip in the upper left, temperatures bottom right. Now, if you recall, in January, I think there's going to be some sort of large ridge in western Canada, which will extend into central Canada. And that would produce, that would shut off the moisture in the northern and southern Canada area and over the Dakotas and Minnesota. And it would also impact the amount of the temperatures here as well. If you have that, if the ridge is on the west coast, obviously western Canada, southwest Canada would be above normal probably. But if the ridge is a broad ridge like this and extends into central Canada, what happens is this area stays above normal relative to normal. So there, and that also implies again, if I think my forecast is right, we'll have a fairly deep trough in the eastern Pacific to California, and then one along the southeastern coast and off the coast there. So this would keep your southern storm track in that direction. That's what I'm kind of favoring here. You can see that with the above normal precipitation. So that's how I see January. I'll take a look at February. Now, February is where things look awesome. I mean, the models just continue to show February really rocking here. All of the models have turned towards the European solution, which has been pretty bullish here for a while. And again, if you look at the long version here, and you see the climate models, you'll see they all have turned towards the European. So we continue to see a very strong southern jet stream, and that's the thing that's really quite noticeable on all of these climate models, not just the European, the Japanese, the British model, the Canadian. Very strong southern jet stream, and that with a weak to moderate El Nino, that's actually a very common high probability event. So the precipitation is near normal in here. There are some of the data shows actually a little drier than normal up in this area, but I'm just going to go for near normal. And then above normal is the deep south, again, southeastern coast up the east coast here. And then precipitation with a lot of blocking. The temperatures, I think it's going to be below normal in the northeast, and then much below normal, I should say. and which is pretty bullish for me because when I do seasonal forecasts, I don't like to go a much above normal or a much below normal. I don't think I'm not confident doing that most of the time. But here, for the seasonal forecast, I'm pretty bullish about February. And then you can see the normal and above normal on the west coast there as well. And then finally, we look at March. Here we go for March. Now, the reason why I have a below normal precipitation in the Dakotas, eastern Dakotas, Minnesota, Wisconsin, the Great Lakes here is because I think the trough is so deep that it actually may be too cold to snow, or it's a deep trough here. So you're getting a direct flow out of Canada, which is a dry flow for this area. So that's why I've got them below normal precip. And then the trough is pretty big, and you get a big nice storm track in this direction. You can see the trough here by the below normal temperatures in that area as well. This could be more in the East Coast. It's possible. It may be more out a little to the west, so we have time to adjust on March as we see fit. But I think March is also, I think, going to be a pretty darn active month here. So that's my detailed breakdown of the forecast. Now, if you want to reach me for whatever reason, again, you can reach me through my Gmail account. That's probably the best way. I also have a Verizon one, and a Yahoo one, but that's the Gmail. It's the best one. Now, this is my commodity account here on the Twitter, so you're following that. Mostly there I post, U.S. grain weather, Russia, Australia, China, India, what have you, South America. But so if you're following me operationally for snowstorms and for what patterns in the U.S., this is the account you want to follow here, the DTVA Weatherman. And there's a picture of my smiling face from Richmond, from Chesterfield. And that, of course, obviously the Facebook page. Most of you probably already know that. But if you don't, you can always contact me that way as well. And also wanted to point out here that for the winter season, I do offer a couple services if you're in snow removal or landscaping, construction, if you have farms which have conditions, ski resorts. It's amazing how important and impactful the weather is on so many different operational forms of business. I first started this by just doing commodity forecasting, and now it's spread into the operational area. So one of the things that I offer is a daily operational forecast. It's $35 a month. I will tell you that because it's on the website. And it comes out several times a week, at least 3 times a week, sometimes 5 or 6 times, depending on the weather. And you get the Mid-Atlantic region in breakdown of the 13 different zones, and you get a week 2 forecast, and you get sky conditions and temperatures, humidity, winds, precipitation, the whole thing. So it's like a really good bargain, only $35 a month. And you can get that to the website. So just go there if you want to sign up for it. Another one is the snow removal forecast. And here, the price, you don't have to call me because, well, if you're one person or 2 people and you're operating a truck, that's one thing. If you're operating and clearing 500 different shopping centers, that's a total, and you have 50 trucks, that's a totally different setup. So, but the snow removal forecast is really good. It has a lot of information in it, and I get a lot of compliments on it. They think a lot of the snow removal folks in the Mid-Atlantic think it's a unique product, so you might want to take a look at that. This is the weather notification service, which goes out 365 days a year. 7-day notice of any sort of significant weather that might impact you, whether it's whether it's high heat or extreme cold, snow or ice, major rain, flooding, drought, severe weather, hurricanes, whatever it is. If the weather's fine and sunny like it is today, you don't hear from me. If there's stuff coming down the pike and you need advance notice, starting 7 days out, you start getting emails and notifications from me with a weather notification service. And also, finally, we have a texting service that goes right to your smartphone. We use WhatsApp for that, and also the SMS texting service on the smartphones. And then also the 30-day forecast for the eastern half of the country has above normal, below normal temperatures, above, same with the precip. Shows you the general pattern. There's some meteorology in it. It goes out to 5 weeks really, and it comes out every Tuesday. Sometimes it's an update on Friday, depending on conditions. And this is a very popular product as well. It gives you a really good notification and change when the pattern's coming up, when the winter, and that way you can have an idea, when is the rainy pattern going to end, when is the cold going to show up, that sort of stuff. Anyway, so that's the adjustment I've made to the video, and hopefully the new maps there clear up any confusion. Sorry for putting the wrong dates on it. Just one of those things mistakes that you're going to make with a lack of sleep. This is meteorologist DT from WXRISK. I'll see you on the Facebook page and on the Twitter page.